Okay, so this is a very popular game, The Long Dark, actually one of my favourite games. But it's been around for like more than 10 years, development, constant development, yet they've failed to fix their first-person physics character controller all this time. So if you hit like a 1 inch snow, look at this little thing, boom, stop. Well, I'm stopping over that. That's exactly what happens. You might be running at full speed, getting away from the weather or a predator or something, and suddenly you stopped just like that. It's really silly, actually. That's terrible. Um, should never happen. You know, like boom, just like that, flat out, full speed. You can tell me that little bit is going to stop me, and that as well, that tiny bit. Well, that's how the Unity physics character controller for this game is. Still haven't fixed it. Mentioned it before, I think in the forums and a few things, but anyway, so it's a common problem with all physics character controllers, actually, and CopyCube does the same thing. I'll show you that now. Okay, so this is CopyCube demo test scene. Got some stairs and a few things here, and try and climb up. Normally what would happen is you hit a little tiny step and that's it. You can't climb it, can't get up there. The little head bobbing thing is going, but can't climb it. Same with this. Hit it. It went over that tiny little one, which is almost nothing. It's basically in the ground almost. But this next one I couldn't get up. Physics character control, they've all got this problem, and there's different ways of getting around that problem. One is to shoot two collision points to see at the point down below near the feet of the player shooting forward, is it hitting an object within a certain distance? If so, shoot another one above around knee height, where the maximum climb height you want to get over, and say, does that also impact it at the same distance from the player, or is it like a step where it's further back, so I should be able to climb it? And then it determines, okay, well then lift the player up off the ground. Well, that's actually works quite well, but I tried another solution that may actually be better, because there might be some limitations. I haven't fully tried that first method. I tried another way, and I had a nice workaround that may actually even be better. So when you shoot a collision point line from the player, what if it just misses the like a single step or a thin object you're trying to climb over? What if it's just below it or just above it and misses it completely, yet it's still an obstacle? That might be an issue, actually, with that method. But anyway, I didn't need that, because I created my own method, and I actually found it works really well. Okay, so this is my version how it works. So got your head bobbing, of course. Now he hits an obstacle and climbs over it. Nice. Notice a bit of a slowdown as it climbs over it. That seems quite realistic. I like that, actually. Works quite well. Up steps he goes. Yep, no problem at all. On the whole, works pretty good. Probably could do a tiny bit of tweaking, but I think I got it to a pretty good level. Little bit janky, just tiny bit little there. I mean, you can make some adjustments for that. But yeah, it actually works really well. Pretty happy with it. Going that way and going this way, or whatever way, just climbs over it really nicely. Yeah, it works really good, actually. I'm quite happy with that. Now I'll show you the code. Okay, so C++, I'm not even a C++ programmer, but anyway, I got it to work. So I've got these variables I set up. Okay, we've got starting position of that particular frame, the previous end position of the previous frame, percentage movement, expected move, or expected movement for that frame, the actual movement for the frame. So that's check the following frame to see how much you expected to move, and then how much you've actually moved, and then if it's above a certain percentage of the move, then climb up that amount and do a count. Like actually it limits how many times it does it, so it doesn't just keep doing it either. So it starts, it will stop eventually, so it limits how high. So the climb count and the climb up amount will determine how high it can climb up once it finds something to climb over. Alright, so we got then we just initiate the variables, give them a start position, and previous end position will just be the starting position in the beginning to start with. The percentage movement, I found around 60% actually worked quite well. I originally had it 90% or 95%, and I mean that'll work, but it tends to give a bit of a head bobbing effect all the time. But it wasn't particularly smooth, so I didn't use that. And also walking at low speed, a little bit jittery. So the lower this number, the smoother it became. Now that should be 0.15. Around about 0.1 or 0.15 for this is for CopyCube. For different game engines it'll be different, of course. This is the vertical height amount per frame to push the player up if it encounters an obstacle to climb over. This is just the float's expected movement amount, and this is the actual movement amount. So it just compares what you expect to move for that particular frame compared to what you've actually moved. And if it's less than a certain percentage, then push the player up, basically up, and only for a certain number of times, then stop. So it doesn't just keep climbing up over things forever. Yeah, and that actually works really well. Expected movement, that will be calculated. How I've done it is that after all the code is done, this pos or position gets adjusted for smooth moving, and according to the keys of the player, forward, back, left and right, all gets calculated, normalized, multiplied by the movement speed versus and delta time, and the position gets updated according to that, what the player is wanting to do. So that's what the player wants to move by the amount, but if it hits an obstacle, then it obviously won't be able to do that. But anyway, so that pos amount is the desired movement amount. Position, in other words, actually that's actual position, but I just wanted the actual net distance movement of the expected that we want. So I've decided to take the position to move the player for that frame minus the visual starting position. So that's the total vector distance for that frame, and then just get the length. So it's just a float value for the expected move there. Now the start position is obviously just so at the start of the code when it runs, it's getting the delta time and all that sort of stuff. So we got so the previous end position is basically the starting position of the previous frame, and the new starting position for this current frame will be just the get position before the code runs. Will just be the position, camera get position. This is what the actual position of the player is. So the new start position on every frame, this is line 200 is basically the main code, runs every frame. But that's comparing this current camera position versus the starting position of the previous frame. So it's going to look at the actual movement between those two and see the actual position moved versus what was wanted to be moved, and compare the two basically. So this that's not part of my code. That's standard for other stuff. Now this is where I use my stuff, actual movement. So I've got here delta position, or the change in actual position is the previous end position minus the starting position. So it's actually looking at the actual movement. And there it is there. Actual movement, as in a length of the vector, is the change in pos or delta pos, the get length. So the length of that, it's a float amount. So I'm saying if the actual movement float is less than the expected movement float amount multiplied by percentage, here it's about 60%, then, and the climb count. So I'm not going to just keep running this forever, so I'll have a limit, say, of 5, 6, 7 or 8 climb counts, to stop it. So it'll only run for a certain time and then stop. So you can't just climb, you know, near vertical walls and stuff like that. It'll just, yeah, so it'll stop, has a limit. Then, if it's within that climb count starts at 0, then the climb count will run, it'll increase by 1, and the position.y, vertical value of the player, push it up by the climb amount. And this, in my case, it's about 0.1 or 0.15, so it's a pretty small value, but it's enough to push the player up over things. And if that's not the case, then I found the best method was just to reduce the climb count by 1. Wouldn't immediately put that to 0, that will not work, right? And then if it climb count's less than 0, just keep it at 0. So that works quite nicely, and that's only if you're trying to move the player. If you're not trying to move the player, this is not going to run. So if you take your finger off the keys to move the player forward or whatever, it'll then just revert back to climb count is back to 0, resets back to 0. The try move, I've renamed a lot of these variables to make more sense. So that's basically saying, are you trying to move the player, yes or no? Starts, if it's paused, then false, but by default it's false, unless of course using the keyboard keys, forward, backwards, left or right, then the try and move would be true. So it's just because you move the keys forward doesn't mean the player will always move how you want, because it might be hitting an obstacle, so that's why I've called it try and move. Yeah, so if you try to move the player, the actual movement ends up, for the previous frame, ends up being less than the expected movement from the previous frame multiplied by a percentage amount, like 60%. Then move the player up for a certain, up until like 8, 7 counts or something. I've tried 6, 7 and 8. I mean, you're somewhere around there is quite good. Percentage amount, I did have 90 to 95%, but it works, but at low speed it causes a bit of jittering. So I actually find that 60%, or you could probably go 50%, is a lot smoother. So in other words, it doesn't run very often, only when it really hits an obstacle. At a 90 to 95%, it was basically running all the time, even when it was not hitting an obstacle. I don't know why. Even when you're walking on flat ground, it was still running. It was weird, and it was having this like head bobbing effect. Not very smooth head bobbing, but it was a head bobbing effect around 95%. But I won't use that. So I think 60% is a better idea. Yeah, and that actually works really good. It's just a bit of simple code, just done in the right way, and that'll work quite nicely. Yeah, and that fixes all your problems. Yeah, so if you hit a solid wall, it's not going to climb the. See, it goes up a tiny bit and stops. Yeah, that's how it's supposed to do it. Go up a little bit and stop, just a fraction, not too much. You could say it's a bit jittery there. Yeah, that's just how it works. Goes up a tiny bit and stops. Yeah, that's totally acceptable in my opinion. It's not going to climb the wall, no. So that's quite good actually. I think a lot of games have implemented something similar. But anyway, so this is what I come up with, and I'm pretty happy with it. Actually, it works really nicely. He slows down a bit when he encounters an obstacle. Yeah, it works well. It's not too jittery. It's reasonably smooth. Pretty happy with that. Yeah, it's good. I probably should change the head bobbing so it's directly linked to the movement, actual movement of the player. So if he hits a wall, he's not going to be head bobbing, is he? Keep walking. No, it doesn't make any sense. So I probably should stop that. Anyway, yeah, so that's pretty good. Happy with that. Yeah, so before, in my opinion, physics character controller that gets stuck on the smallest of obstacles is not a usable character controller, yet for some reason some games has continued that for over a decade. Yeah, Hinterland, you might want to fix your game up. I'm not even a C++ programmer, but I worked it out, so there you go. Hope that helps someone. Cheers.